Hello all, I'm Dr. Rizvi and this is lecture 4 on simple stress and strain. And in this lecture we will discuss the topic stress and strain in step bar. So let us start with the topic. Here the first image, the figure 1, you can see that a stepped bar of section 1, 2 and 3 is shown that is acted upon by a force P on both the sides. Length of the sections are given as L1, L2 and L3 and the areas are given as A1, A2 and A3. To solve these types of questions, we have to find the since we have to find the change in length in the bar, so we have to calculate the individual change in length of all the three sections. Here we have three sections 1, 2 and 3 of the bar. So first of all, to solve these types of question, we will make the free body diagram of all the three sections like this. This is section 1, this is section 2 and this is section 3. Since the bar is subjected to force P, so all the sections will be experiencing same force P, and the lengths are L1, L2 and L3. As we know that uh, according to Hooke's law, sigma equals to epsilon into E, the elastic modulus, and epsilon equals to sigma upon E. We also know that sigma equals to P upon A, force upon the cross-sectional area, and epsilon equals to del L upon L. So from here, del L upon L equals to P upon AE. So the change in length will be equals to P into L upon AE. This will be the change in length that will be calculated for each section. So the total change in length, the total change in length of the stepped bar will be equals to del L equals to del L1 plus del L2 plus delta L3. It will be the summation of change in length of the section 1, change in length of section 2 and change in length of section 3 equals to P. Since the length of each section is different, so P L1 upon area is also different and the material of the bar is same, so E will remain same for all the sections, plus P L2 upon A2E plus P L3 upon A3E. So the total change in length of the bar del L will be P upon E will be constant, so P upon E whole divided by L1 upon A1 plus L2 upon A2 plus L3 upon A3. By this formula, we can calculate the change in length of the step bar that is acted by a single force. Remember this formula while solving these types of numerical. So now we will solve the numerical given here. Here you can see that a 600 mm long bar 200 plus 200 plus 200, 600 mm, a long round bar of copper. The material given here is copper bar, and it is having a diameter of 30 mm for length of 200 mm, 20 mm for length of 200 mm, and 10 mm for the remaining portion. And it is subjected to a force of 30 kilonewton tensile force. We have to find out the total elongation of the bar, and here the modulus of elasticity or Young's modulus is given as 100 kilonewton per mm square. So as we know, initially we have to draw the free body diagram of the three sections of the bar: 1, 2 and 3. We have to depict the load 30 kilonewton, 30 kilonewton and 30 kilonewton. Its diameter is 30 mm, its diameter is 20 mm, and its diameter is 10 mm. Length is 200 mm, 200 mm and 200 mm. Now we will solve this numerical. Initially we will find out the area of each cross section. So A1 is pi by 4 d1 square, diameter is 30, so pi by 4 into 30 square equals to 706.86 mm square. Similarly, we'll find out the cross section of area 2 having diameter 20 mm and it is 314.16 mm square, and finally A3 having a diameter of 10 mm. A3 is 78.54 mm square. After finding the areas of the cross section, we will find the uh, stresses, that is the value of P upon A, or uh, we can finally write the value in del L. Del L equals to del L1 plus del L2 plus del L3, that is P is constant and E is constant, so P upon E, L1 upon A1 plus L2 upon A2 plus L3 upon A3. P is 30 into 10 to the power 3 since it is 30 kilonewton, and upon E is given as 100 into 10 to the power 3, 100 kilonewton per mm square, and in bracket we will write the value of L1 upon A1. L1 is 200 mm upon A1 is 706.86 plus L2 is also 200 mm upon 314.16 plus L3 is 200 whole divided by A3 78.54. On solving, the change in length del L value will be 1.038 mm. This is the final or the total elongation of the stepped bar as shown in the figure and subjected to 30 kilonewton load. So this is how you will solve these types of numerical based on stress and strain in stepped bar. Thank you.